Hi, we are the ECE Team 2212 members Joseph, Justin, and myself, Daisy. Our project is on electromagnetic expulsion of a cylindrical body from an outer tube.
This is a continuation project sponsored by the Naval Undersea Warfare Center. Additionally, it is a joint project that we are completing with Mechanical Engineering Team 34. The main goal of this project is to create an electromagnetic launcher prototype to launch a cylindrical body from an outer tube into a body of water. Additionally, our goal is to collect exit velocity data in terms of varying payload mass and input energy to the system. The main components of the launch system are three solenoids. A solenoid is a device that creates a magnetic field by passing current through a coil of wire. This magnetic field induces a force on an iron slug that is in the back of the sled to pull it to the center of the coil of wire. In order to not pull the payload backwards into the coil, the timings of the coils must be tightly controlled in order to release the payload at the appropriate time, not pulling it back into the coil.
This is the schematic for our project. The power input is on the left, the energy storage is in the middle, and the coils and coil switchings are on the right. The entire circuit is controlled by a microcontroller to implement precise coil timings. This is the physical implementation of our circuit schematic. The power input, coil switching, and microcontroller are at the bottom. The energy storage is in the middle, and the coils are on the tank.
Through a series of calculations, the predicted exit velocity of the submerged payload under the varying conditions are represented in these plots. In general, the data indicates that the payload is to experience the highest velocity underwater when there is a high voltage applied to a low mass payload. These are the simulated exit velocities of the launcher based on a finite element method magnetic simulation, or FEMM. This three-dimensional plot supports our hypothesis. There is a positive correlation between the capacitor voltage and the exit velocity, as well as a negative correlation between the mass of the projectile and the projectile velocity. These are the experimental results of our submerged testing. These results are compared to the simulation data obtained via FEMM analysis. According to many of these data points, our projectile exceeded our expected results. This outcome may be beneficial if the project was modified to accept a longer projectile, in which more time would be required for the payload to clear the tube before deceleration caused by dynamic fluid forces reduces the velocity to zero.
This is a demonstration video of a successful submerged test launch. As we will see, the payload exits the tube with considerable velocity and travels nearly the length of the tank. Additionally, this exit velocity that we recorded is in line with the FEMM simulation described previously.